Okay, welcome to lesson 17 of module 4. We are going to continue talking about slope and talking about linear equations. In this lesson, we're going to look at a particular form of a linear equation. We've looked at standard form, which is ax plus by equals c. And we've looked at what happens when we change the values of a, b, and c, especially when we let either a or b be 0. We saw that those were vertical and horizontal lines. So this is the standard form of a linear equation. There's another form that we're going to talk about today and focus on, and it's y equals mx plus b. And I want to point out right now that the b's in these two equations are different. They're not referring to the same b. They mean something different in different situations. Okay, so we are going to start. To get started, we're going to look at exercises 1 through 3. These you can do independently. You're asked to find 3 solutions, and remember, a solution is an ordered pair that makes the equation true. So you're going to work on y equals 2x, y equals 3x minus 1, and y equals 3x plus 1. So you'll have 3 separate graphs. This time we are going to connect the points to make a line, and you're asked to find the slope of the line in each of those cases. So you need graph paper for this because it's not provided in your classwork pages. So get a couple sheets of graph paper and graph those 3 equations, and then come back and we will talk about them. Okay, here is a sample result for exercise 1. The equation is y equals 2x, and the ordered pairs that are on this graph are 0, 0, 1, 2, and 2, 4. You might have had others. You might have chosen a negative number, which would have been great. You would have had -1 and -2. That would have been a point on this graph. You might have had others. You might have picked larger y's. So whatever you pick, just make sure that your graph looks similar to this one. Okay, let's look at exercise 2 now. Okay, here's exercise 2. This graph was y equals 3x minus 1. When we put in 0 for x, 3 times 0 is 0, minus 1 is -1. When we put in 1 for x, we get 3 times 1 is 1, minus 1 is 2. So 1, 2 is an ordered pair. That is a solution. When we put in 2 for x, 3 times 2 is 6, minus 1 is 5. So we've got 2, 5. So there's those ordered pairs, and the line has been connected. So there's exercise 2. Let's look at exercise 3. Okay, and again, here are sample solutions for exercise 3. You could have chosen different points. If you choose x is 0, 3 times 0 is 0, plus 1 gives you 1. For x of 1, 3 times 1 is 3, plus 1 is 4. And for 2, 3 times 2 is 6, plus 1 is 7. We could have had a negative. What about -1? 3 times -1 would be -3, plus 1 would be -2. Okay, so there would be another point on your graph. Okay. Okay, so in addition to graphing each of these, we were asked to find the slope. So here's exercise 1 I came back to. Exercise 1, I can draw a slope triangle with a 1 unit distance on the horizontal axis. So I can read the slope right here as 2. So for this graph here, the slope m equals 2. The slope is 2 here. Okay, let's look at exercise 2. Once again, I can find that 1 unit horizontal distance and read off the slope right here, and it is that ratio. Anyway, we saw in the last lesson that no matter what 2 points we choose, because we end up with these similar triangles, the ratio is going to be the slope. So in this case, the slope m is equal to 3. In this case, 3 over 1 up in this triangle. For this larger triangle, we'd have a horizontal distance of 2 and a vertical distance of 6. 6 divided by 2 is still 3. So slope in this case is 3. And for exercise 3, once again, we have a slope of a horizontal distance of 1 right here, a vertical rise of 3. So our slope again is 3. And notice all 3 of these exercises are positive slopes. Okay, now you don't have this in your notes. You can take some notes if you'd like. We're going to look at just the general, a general line here. So this is the blue line, contains point x, y. Okay, so what we're doing in these lessons 16 through 18 is we are trying to gather some information that's going to help us prove that the graph of a linear equation is a line. We've graphed them, we've graphed many points, and we've made predictions that they're lines, but we haven't proven it yet. So we're on our way to do that, and we'll pull that together in the next lesson. So for now, just follow along, and this is going to be kind of cool. So okay, so here's the blue is a line. It's got the point x, y on it. Okay, so what we're going to do is we're going to add another point on this line. And I'm choosing this point with an x value of 1. And that's because it's going to have the y coordinate up here of m. Excuse me, right here, of m. Because remember, that's going to be the slope, right? That's how we started out with the definition of slope. When there's a horizontal distance of 1, then the rise is the slope. But we also know that we can use any ratio because we have something special going on with these similar triangles, right? So we've got another point x0 on the x-axis right below xy, and you can see these similar triangles that we've been talking about. One there, and then the smaller one here. Both of those can be used to find the slope. So what I want to do next is I want to show that a particular ratio is true. I want to show that, let me pick a different color here. We'll go with blue. I want to show that y over m is equal to x over 1. So see if you can look at that diagram and see how you would show those two ratios to be equal. Where can you find those quantities y, m, and x and 1? So go ahead and pause the video and work on that, and then don't try too long. If you're not sure where I'm going with this, then just follow along. Okay, so let's look where, well, let's restate. These are similar triangles, the large one and the small one. And so let's talk about why they're similar, just in case you've forgotten. They both include this angle right here that comes from the origin between the x-axis and the line itself. And they both have a right angle here, where these red lines meet the x-axis. So because of the angle-angle criteria, if I have two angles that are congruent, two corresponding angles in two different triangles that are congruent, then we know that the triangles are similar. And remember, we actually know that these angles up here, this one and this one, are congruent because they are parallel lines. The red are parallel lines cut by a transversal, and those would be corresponding angles. So we have all three angles of these triangles congruent, so they are similar triangles. So because they are similar, their ratios of corresponding parts are going to be equal. So let's see where we can find these ratios on these triangles. So looking at this distance here, I know that this distance here is equal to y, because from the x-axis up to the point here, the value of the y-coordinate is that distance. Okay, so that distance is y. This distance right here is m. Okay, so those are corresponding points on that triangle. So that gives us the first ratio in this proportion. So y over m. And then I have this distance here, this whole distance here is x, because that point is at x0. And then the shorter distance here I chose to be 1, so that I could have the slope as part of this equation right there. So I've got x over 1 is another ratio for these similar triangles. So I have y over m equals x over 1. Okay, so if I do multiply both sides of this equation by m, or I can do the cross multiplying, however you want to think about it. But let's say I multiply both sides of that equation by m, then I would get the equation rearranged, but it's equivalent. Y equals, and I'm going to put the m in m times x. We like coefficients in front of the x term. It's just a convention. I get this equation, y equals mx. So anytime I have a line, and this is a special one, notice it's going through the origin. Anytime I have a line going through the origin with just a random point xy and a slope of m, it's going to be in this equation, in this form, y equals mx. So whatever I put in for x multiplied by the slope is going to give me my y value. Okay, and another way just to rephrase that, if I have an equation that's written in this form, y equals some number times x, I know that that number is the slope. So if you turn back to exercise 1, we had the equation y equals 2x, and notice that the slope was 2. So y equals 2x, the slope is 2. Okay, now I'd like you to look at this diagram and notice what's different about the blue line here from the example that we just did, this one. Okay, so you might notice that the graph is very similar. It's a positive slope. It's got a point xy labeled on it, but it's been translated from the origin up to this point B on the y-axis. So I'm going to label a few things here for us. All right, so let's look at this diagram. So the line has been translated up. It doesn't go through the origin. So let's look and make sure we can make sense of the coordinates of all these points. So where it crosses the y-axis right here would be the point 0b, because x is 0, and then we're going to use b to stand for wherever this is crossing the y-axis. It could be anywhere along here. Okay, so I've drawn this horizontal line here to show you where y equals b is. All right, so we're going to draw our triangles down. We're going to draw our slope triangles. Once again, we're coming over here 1 unit to where x equals 1 and y equals b. So that's why these coordinates are 1, comma b. And then up here, the x coordinate is still 1. So that's where we get this. The y-coordinate, we're going from B, and remember this distance here is m. So that's our slope. That's why we've chosen that horizontal distance of 1 here, so that we could have the slope on this diagram. So, so if we're already at y equals b here, we go m units up, then our y-coordinate is going to be m plus b. Okay, so coming over here, y is still b all along this line. So there's our b, the y-coordinate. And then we've chosen our sort of generic point xy. So this would be the x-coordinate. So this would be x comma b, and this was the point we started with, xy, on our line. Okay, so we've got similar triangles again. That one and this one are similar triangles. So we're going to set up some ratios and see what the equation of this line is going to look like. And this is going to be pretty cool. Okay, so as we set up those ratios, we're going to need, we already determined the length of this segment here is m. But what is the length of this segment here? So you might want to pause the video and think about that and come back and we'll continue. So what is the length of this segment of that larger triangle? Okay, so let's think about this. So the y-coordinate of this point is y. The y-coordinate here is b. To find, if we went all the way down to the x-axis, this distance would be y. But since we're only coming down here, the distance is y minus b. So that's the length of that side. That doesn't look very clear. Of this side of that triangle would be the quantity y minus b. Okay, so now we can write the ratios. So we know that y minus b over m is one of the ratios in those similar triangles. Again, this length to this length. Now we can write the ratios for the horizontal distances. So from this point back to the y-axis is going to be a distance of x. Okay, so we've got a distance of x there, and this distance again is 1. All right, and so if we do, once again, we could multiply both sides by m. What we want to do here is solve for y. We want to get y equals some stuff over here. Okay, and so if we multiply both sides by m or cross multiply, we get the same result. So let's cross multiply. Here we go. We did it the other way the next time. So we're doing that, right? So we get y minus b times 1, which is just y minus b. And that should equal, right here, m times x. Or it does equal, not it should equal. Okay, so we've only got one more step to get y by itself, and that's to add b to both sides of this equation, plus b. Okay, so, let me get my color. So we end up, after this step, we end up with y is equal to mx plus b. Okay, so this would be the general form for a line that is, you know, going through the y-axis and coming up like that with just a general point xy. Here would be y equals mx plus b, where m is the slope Okay, m was our slope. So what is b, though? So where could we find b on the graph? So think about that for a minute. Okay, while you're thinking about where b is, we do know that the slope of a linear equation in this form would be m. So let's look back at exercise 2 and 3. Okay, so here's exercise 2, and our equation is in this form: y equals mx plus b. And notice that the slope of this line was 3, and there's m in this equation right there. And let's look at the next one, y equals mx plus b. The m is the multiplier on the x term, and the slope is equal to that value. Okay, consider again the exercise 2 equation, which was y is equal to 3x minus 1. We found 2 points on that line. When x was 2, we found y is 5, and when x was 1, y was 2. So when we wanted to compute the slope, remember we said we're going to look at that vertical distance here and divide it by the horizontal distance. So to find the vertical distance, that's the difference in the y-coordinates, 5 minus 2. The horizontal distance is the difference in the x-coordinates, 2 minus 1. And so we got 5 minus 2 is 3, 2 minus 1 is 1. So the slope was 3 in that equation. And we see it right there. Okay, so what we want to do now is we're going to use that general method, but we're going to look at just the general equation that we've come up with here, y equals mx plus b. And what we want to do is show that the slope is this number m. So we're going to choose 2 points, point P, and it has coordinates P1, P2. We're going to choose point R, and it has coordinates R1, R2. And we're going to substitute them into this equation and solve for the slope. So if point P1, P2 is on this graph, then I could put in P2 for y and P1 for x, and the equation would be true. So that would give us this. We could say that P2, which is y, is equal to m times P1 plus b. And I could do the same thing for point R. So the y-coordinate, R2, is equal to m times the x-coordinate, R1, plus b. Okay, so I've got these two equations. I know these are true because I've said that points P and R are on that line. Okay, so what we want to do now is we want to write an expression for the slope. So the slope of this graph, and I'm just going to say slope. I don't want to use m because I want to prove that the slope is m. So the slope is the difference in the y, P2 minus R2, divided by the difference in the x, which is P1 minus R1. Okay, so that slope is going to equal P2. Now P2 is equal to this expression, and R2 is equal to this expression. So what I want to do now is substitute those into my equation. So P2, I'll do this one first, minus R2. So P2 is m times P1 plus b. and I'm going to subtract R2, which is m times R1 plus b, and that is still all over P1 minus R1. Okay, now I'm going to continue simplifying. So I get m times P1 plus b. Notice I've taken the parentheses off. But for the other parentheses, I need to be careful because I'm subtracting everything in the parentheses. So I need to distribute this negative 1 into that. So I've got, notice it'll be minus m times R1 and then minus b. Still all over P1 minus R1. Okay, so now I can notice that I have a b term, and I'm going to make this plus a negative b. So the positive b and the negative b become a zero pair, becomes 0 when I add them together. So I can simplify this even more. So I'm going to write this as equals m times P1 minus m R1 all over P1 minus R1. Okay, so maybe you can see what this next step is going to be. And what I'm going to do is I'm going to use the distributive property again, and I'm going to factor an m out. So I'm going to write m times, so for this first term, be m times P1 minus m times R1. So I can rewrite that as m times the quantity P1 minus R1. So let's look at that to make sure. So we went from this step here to this step here. So notice if I take m and I multiply by P1, I get this term back. And if I take m and multiply it by R1, I get this term back, and it's a subtraction, so the subtraction's there. So this, this works here. So one last thing to do is to notice that I have P1 minus R1 in the numerator and P1 minus R1 in the denominator. So those can cancel out because they become a factor of 1. So I can, those become a factor of 1, which leaves me with this whole expression is m. So what I've shown is that the slope is this number m from the y equals mx plus b. Okay, so that's important again because in when we started this series of lessons, our whole goal was to show that these equations that we've been graphing, that we're predicting our lines, are indeed lines, that we can fill in those extra points and actually draw the line, and it will be a correct representation of that equation. So now we know that when an equation is written in the form y equals mx plus b, oops, y equals m times x plus b, that the slope is easy to recognize that the slope is m. And we know that for any 2 points on that graph, the slope will be m, will always be the same, regardless of what the 2 points are. And remember, we started with equations in standard form, which looks like this: ax plus by equals c. And we notice that the slope isn't easy to recognize when the equation is in that form. But what we're going to look at now is that we can take an equation in this form and transform it with properties of equality into that form. So let's do an example now. We're going to do an example with a particular equation here. And the equation I'm going to work with here is 8x plus 2y is equal to 6. And what I want to do is transform it so that y equals some number. Okay, so I'm going to start, and there's different ways you could do this. I'm going to start by subtracting 8x from both sides. Okay, so when I'm done with this step, and let's draw this line down. When I'm done with this step, I'm going to have 2y on the left-hand side of my equation and negative 8x plus 6 on this side. Now I could have written 6 minus 8x, but a convention is to have the term with the x come first in that expression, so I just chose to write it that way to start with. Okay, so now I know what 2y is, so I'm going to be dividing both sides by 2 so that I can get y by itself. So notice I'm dividing this whole side by 2 here, so we'll straighten that out in a minute. Okay, so the left side of the equation is now y equals something. And so y equals this quantity over here. So I have negative 8x divided by 2 plus 6 divided by 2. Because when I divide that side of the equation by 2, which is the same as multiplying by 1/2, every term there is going to get the division or the multiplication. So y is equal to negative 4x plus 3. Okay, so I used properties of equality and I transformed 8x plus 2y equals 6 into y equals negative 4x plus 3. So if I graphed both of these equations or looked for solutions to both of these equations, they would have the same graph and the same solutions. The advantage of having it in this form is that I can read the slope easily. So standard form and this, which we're going to call slope-intercept form, this other one down here, slope-intercept form is this one, standard form is this one, are just two different ways of writing linear equations. So the slope of this equation is negative 4. Okay, go ahead and work independently on exercises 4 through 11. They should go pretty quickly for you, and then just come back and we will go over your results one by one. Okay, so for exercise 4, it just asks what is the slope of this equation, y equals 7x minus 3. So it's in the form of y equals mx plus b. So we can identify the slope as the coefficient of the x term. So the slope of this equation is 7. Okay, and then the next one, 5, the coefficient of the x term is the slope. So the slope here is negative 3/4. Okay, let's look at number 6. You have $20 savings in the bank, at the bank. Each week you add $2 to your savings. Let y represent the total amount of money you have saved at the end of X weeks. So y is the total amount saved. Write an equation to represent this situation and identify the slope of the equation. What does that number represent? Okay, so first we have to write an equation before we can identify the slope. So if y is the total amount of money you have saved, I'm going to write just a verbal equation because this helps some people. So the total saved should equal what I started with, the dollars I started with, my total saved should be the dollars I started with plus my weekly savings. Okay, so that's kind of a verbal model of that problem. Okay, so I'm told that the total, I'm going to let y be the total saved. So let's get a different. So the total saved is y. That's going to equal the dollars that I started with, which was 20, added to my weekly savings. So I'm told that X is going to be the number of weeks. And each week I add $2. So my weekly savings are going to be $2 times the number of weeks. So my equation is y equals 20 plus 2x. And I might want to turn that around into the more standard, or not standard form, but the conventional form, which is to put the x term first. Y equals 2x plus 20. And I can see that the slope is the coefficient of the x term. So the slope is 2. And what does the number represent? So the number represents the amount that I saved each week. So you could think of it as the change in my savings account. So the slope here is how much is my savings changing on a weekly basis, and it's changing by $2 every week. Okay, let's look at number 7. This goes back to these constant rate problems that we were doing in the first part of this module. So a friend is training for a marathon. She can run 4 miles in 28 minutes. Assume she runs at a constant rate. Remember, that's important. Write an equation to represent the total distance y that your friend can run in x minutes. Identify the slope of the equation. What does the number represent? Okay, so let's write this equation. So I know that my friend can go 4 miles in 28 minutes. And that's a constant, and so that constant is going to be equal to the, if she can go y miles in x minutes, those two can be set equal to each other because they're both equal to the same constant speed. That is her rate, y over x, or 4 over 28. So I can simplify this. I can write this as an equation by doing a cross multiplication or using properties of equalities, either one. So I can see that 28y is equal to 4x. And if I want to get y by itself, I can see that y is equal to 4 over 28 times x. I can simplify that if I want. 2 over 14 times x. or I could simplify it even further and just call it 1 over 7. Okay, so identify the slope of the equation. The slope m equals 1/7. And and then I want to talk about what does that number represent? Well, if I look back up here, I could see that 4 miles in 28 minutes is the same as 1 mile in 7 minutes. And so that number is actually her rate. So the slope in this equation is her speed, her constant rate, which is 1 mile in 7 minutes. Okay, let's look at number 8. 4 boxes of pencils cost $5. Write an equation that represents the total cost y for x boxes of pencils. What is the slope of this equation? And what does the number represent? Okay, so this might not look like a constant rate problem, but it is, right? Because I'm saying that every 4 boxes of pencils cost $5. And so I can write a ratio. So I can say $5 for every 4 boxes, and that's going to be a constant, and no matter how many I buy. So I would have y dollars for x boxes. Okay, so I've got this relationship here. So I can say that as I write my equation, I can say that 5x, or, oh well, let's do this. 4 times y is equal to 5 times x, and then to solve for y, I divide by 4, and I'll get my equation, which is y is equal to 5/4 x. Okay, so the slope of this equation is 5/4, which is also equal to 1.25, and that would be dollars per box. So our slope in this case is the cost for 1 box of pencils. So it's the cost for 1 box. You could think of that as the unit cost or the unit rate for the boxes of pencils. Okay, let's look at number 9. Okay, 9 asked you to solve the equation for y and then identify the slope. Okay, so again, this is an equation in standard form. We want to put it in slope-intercept form, slope-intercept form, sorry. And we want to put it in y equals some expression, y equals mx plus b. So I'm just going to rewrite it here. So I've got 9x minus 3y is equal to 15. And so my goal is to get y by itself. So I'm first going to subtract 9x from both sides. Or really I could think of this as adding a negative 9x, right? Either way. That leaves me with a negative 3y on the left-hand side of that equation, and then I've got negative 9x plus 15. All right, so what I want to do now is I want 1y, so I'm going to divide by negative 3, but this time I want to show you this a slightly different way. So I'm going to get my green I'm going to take and I'm going to multiply both sides of this by negative 1/3. Okay, so negative 1/3 on the left-hand side, negative 1/3 times negative 3y is just going to be 1y. Positive 1 times y, because the negative 1/3 times negative 3 is positive 1. And then over on this side, I'm going to rewrite this with the negative 1/3 out front. Negative 1/3 times negative 9x plus 15. So this makes it really clear why I have to multiply the negative 1/3 times both terms of that equation, because I've got the distributive property going on here. So negative 1/3 times negative 9 is positive 3, so that gives me 3x. And negative 1/3 times 15 is going to be a negative number, and 15 divided by 3 is 5. So that's y equals 3x minus 5. So the slope would be equal to 3. It's the coefficient of the x term. Slope equals 3. All right, here's another one. Solve the following equation for y. Identify the slope of the line. So we've got 5x plus 9y is equal to 6. I'm going to subtract 5x from both sides, and I get 9. Let's adjust some lines here. I get 9y is equal to negative 5x plus 6. Okay, so now I'm going to divide both sides by 9, and this time I'll do it this way. Instead of multiplying by 1/9, I'm going to divide by 9. So the expressions that I'm left with are y is equal to negative 5x over 9 plus 6 divided by 9. So let's simplify that over here. So y is equal to, this is the same as negative 5/9 x plus, and I can simplify that fraction, don't have to, but I can, 2/3. And I'm identifying the slope. The slope is right here. M equals negative 5 over 9. Okay, that one might be a little bit tricky because I think sometimes people have trouble recognizing that this negative 5x divided by 9 really has a coefficient of negative 5/9 times x. Okay, so if you're struggling with that, you can call me. We can talk about it, talk about why that's the case. Some of this is just getting comfortable with the algebra and seeing how those numbers, it's kind of an order of operations thing too. So, but this is how that's going to work there. Okay? Okay, exercise 11 asks us to solve just the general standard form ax plus by equals c, and to solve that for y so that we can see what the slope is. So we're going to do this exactly the same as number 9 and 10. So we'll start out with ax plus by equals c. And I'm going to subtract off the x term. So I've got, I'll choose a different color. I'm going to subtract ax from both sides. And I'm left with just b times y on the left-hand side of the equation. And I've got a negative ax plus c on the right-hand side. Now I'm going to go through and divide everything by b. Divide all the terms by b, and I'm left with this equation solved for y. And I'm getting y is negative a over b times x plus c over b. So if I have an equation in standard form like this one, I know that the slope is going to be negative a over b. So knowing that m equals negative a over b, what if I went back to exercise 10 and noticed that if I thought of this equation as ax plus by equals c, b is 9 and a is 5, and the slope of that equation ended up being negative 5 over 9. So it's negative a over b. The same thing is true for number 9. Okay, that's kind of an extra for you there. All right, let's summarize this lesson. So what we saw in this lesson was that the line joining any 2 points of the graph of a linear equation of y equals mx plus b has slope m. And the m of y equals mx plus b is the number that describes the slope. Let's always remember the coefficient of the x term. So as we saw in the exercises, if we have an equation in that form, the slope is the coefficient of the x term. So in this y equals negative 2x plus 4, the slope is negative 2. Okay, so you are ready for the exit ticket for this lesson. I am going to give an extra day for this lesson so that you have plenty of time to do a good job on this problem set and to really maybe even look back over your notes and really kind of let this sink in. Try to understand it really deeply. So I want to give 2 days for this lesson, and then we'll come back and look at lesson 18 later in the week. Okay, any questions? Always call. And good luck with it. Have fun.